In this demo, we show how to use Fortran, how to integrate CKFLUID chemistry into a Fortran program. It basically requires one, to compile the chemsource.c into an object file. Use that object file to link together with a Fortran routine that the user want to use. In this case, we use the ChemTest. So basically, there are many ways that one can combine both C program and Fortran program. So the easiest way, the simplest way, is just to turn the C program into an object file and then link it to a Fortran routine. Again, there are two routines needed. So we have those DLL being needed and the 32 bits or 64 bits needed depending on the OS that one is using. So once the user clicks on compile or compute chem, a number of routines are produced. So those routines are stored in the working directory that the user supplies at the beginning. So this is the list of files that are produced once the user has clicked on compile or compute chem. So we have the 32-bit DLL being produced because we run it under Windows XP 32-bit. So, and then we also have the Fortran test routine being used. So for the test Fortran case, we need 3 routines. So these are the 3 here: the chem source, and then the chem kinetics 32-bit DLL, and the chem test is just used to display and show how to use it inside the Fortran program. For the case of the demo, we just use a Visual Compact Fortran and show how it works. So we just include the 2 files inside the same workspace, and then we have to compile. But to make sure that linking takes place correctly, what we do, we just do a settings for the names. For the argument passing convention, we use a C by reference. So that's the only thing that we need to do. We could also change the upper or lower case or use as is, but it's already done inside the chemsource.c. So we don't need to change all that. So that's all one need to do when you use it. So make sure that we pass C by convention. Why? Because if we use the default, so this is what's going to happen. When you link, so there will be unresolved external symbols because this compiler add up some at 12 at the end. So when we do C by convention, it removes it. So we use a C by convention, and then we just compile, and then it compiles very well now. After this, we have to run it. But before we run, we need to supply the actual directory that contains the DLL. So for this case, we have to type in. It's like in C where you can supply it at runtime. We type it inside the code. So let's take that, take it there. So we supply the value. So we put back that, and then we compile it, then we run it. So that then gives us the actual values. So let's just pull it up so we can see what we obtain. So this is what we get under Fortran. So this is what the run gives us. So there are 2 chemistries. The values are displayed, the species, the values for the concentrations, the source terms, and then the reverse rate, the forward rate. The stoichiometry of the reaction is also displayed over there, and then the corresponding values are displayed as well. So that's how we run it. So how the C and the Fortran programs are done. So in this case here, the main looping point is the loop that we have here. This loop goes and then computes the values for the rates, the source terms, and then based on the concentrations that we supply. We are using default concentrations that are created when the chemistry is also created or compiled. These values can be changed at runtime, or any other array of the same size with the values could be used to compute the rate and the source terms as well. So there are two possibilities to call it. One of it would bring or compute the value for the rates. The other one will not compute or get the values from the rates. So the second one is possibly the most general one. And then to use that, so a module is created on top. Inside that module, we have a type that has been created, a chemistry object, which is like a struct in C, which then contains the corresponding variables and values inside here, which is just another type. And then we use that type to make an array, and then that array is being computed inside a routine that we call prepare chemistry. So the user doesn't need to change these routines here. And then this is the display, which is used to show how to access those values and then print them on the screen. Basically, that can be replaced with any routine that computes or that calculates other things by using the source terms that has been computed. So that's the way we use it inside Fortran. So we use some default value for pressure and the total concentration and temperature. So these values can be changed at runtime by the user. So the main point is this line here that's then used to compute the source terms. So this is the main point. The following one shows how to access them, and then that's it. So thanks for your interest in using CKFLUIDSOFT. So we're done.